مساء الخير أيها الحضور الكرام، أهلا وسهلا بكم بلقاء هذه الليلة، ليلة 25 من تموز 2023. محاضرتنا لهذه الليلة ستكون بعنوان Quantum Computing أو الحاسبات الكمية. هاي محاضرة تدخل في فئة المحاضرات التكنولوجية، والتي ربما نكون في أمس الحاجة إليها في هذه الأيام، فهي بكل تأكيد ستساعدنا على مواكبة التطورات الكبيرة والمتسارعة التي تحدث من حولنا في مجال التكنولوجيا والذكاء الاصطناعي وغيرها من المجالات. محاضرنا هذه الليلة هو دكتور رشيد الصفار، وهو طبعا غني عن التعريف، فهو من المؤسسين الأوائل للمنتدى، وهو واحد من أنشط المتحدثين، وسبق له أن قدم لنا محاضرة عن الإنترنت والإنترنت سيكيورتي، وتطرق بها بعجالة إلى موضوع الكوانتم كومبيوتينج في وقتها. أعتقد قبل 3 سنوات يعني قدم دكتور رشيد محاضرة من هذا الباب، واكتفي بهذا القدر من التقديم. وأحب أذكر الحضور أن المحاضرة 40 دقيقة، وتعقبها أسئلة وتعليقات لمدة دقيقتين لكل مشارك. وسينتهي اللقاء في الساعة 10:30. نطلب من الحضور يخلون اللاقطات على الميوت، واستماعا طيبا. تفضل دكتور رشيد.
مساء الخير جميعا، ان شاء الله تكون كلكم بخير وبركه. تشوفون السكرين مالتي مال كوانتم كومبيوتر؟
اي نعم.
اوكي، شكرا جزيلا. محاضرتنا اليوم على الكوانتم كومبيوتنج، بس قبل ما نطب الكوانتم كومبيوتنج حندخل في مواضيع تسهل لنا بحيث لا نوصل الى مرحله الكوانتم كومبيوتنج. اذا ما نعرف التاريخ والهيستوري والمحاولات اللي صارت بها تكون صعبه على الفهم مالته. وانا بالحقيقه مو خبير بالشغله، بس مجرد انه الباك جراوند مالتي بالفيزيكس والماتيريال ساينس ومشتغل بالاي تي لاص 27 سنه، ساعدتني بحيث اعطي كل هاي المعلومات، ويعني مو يعني بالديب ماثماتكس والديب فيزيكس مالته، بس نحاول نوصل الصوره للكوانتم كومبيوتنج سواء تقدرون تسالون الاسئله. فهاي عندنا الاجنده مالتنا، نحكي على الديجيتال كومبيوتنج، بعدين الكوانتم، واخذنا تو يوز كيسز، الالكترونيك اندستري واللوجيستيك الشيبنج، بالاضافه الى اكو كويز بنهايه المحاضره ان شاء الله تكون اجابه. المهم، قبل ما هاي ناخذ لنا فد رحله سفر خلال التاريخ. احنا نعرف ان الستيم باور انجن بال 1700 غيرت الريفوليوشن او المجتمع والسوسايتي. بعدين جت الكهرباء الكتريسيتي، هماتين غيرت، دفعت البشريه نحو التقدم والتطور. بعدين اجى الالكترونيك باور، اكثركم تعرفوها، التيوب والدايود والترانزستور، هم سوت طفره نوعيه وطفره علميه كبيره بالنسبه للعالم. وبالحقيقه 1960 تعتبر هاي فد حد فاصل، هو من سووا اول انتجريتد سيركت او البرنتد سيركت which is basically هاي غيرت الريفولوشن مال كل الالكترونيك والديجيتال كومبيوتنج، وساعدت في بناء الايرلي فيرجن اوف ذا كمبيوتر بال 1960. بالاضافه حنحكي شغله الادفانسمنت بالفوتوليثوغرافي which is هذا علم بحد ذاته. بالاضافه هو مور material mechanical electrical electronic challenges، بحيث وصلنا الى تشيب مالت today which is هي ال 5 نانومتر. بس وصلنا الى مرحله انه كل هاي الشغلات بعد انه من ناحيه الماتيريال ساينس، من ناحيه الفيزيكس لو ستارت بريكنج داون. لذلك حندخل في عصر الكوانتم كومبيوتنج which is حاليا احنا به. بس قبل ما ندخل بعالم الكوانتم كومبيوتنج لازم نحكي على شغلات مهمه.
اسمح لي ابو حسن، انت هسه مخلي على البرزنتيشن مود لانه الشاشه صايره بالعروض.
صار بالعرض؟ انا مسوي برزنتيشن.
صح.
اوكي، شكرا جزيلا. فاحنا حنحكي على هالمواضيع الى كوانتم كومبيوتنج. قبل ما ندخل بالكوانتم كومبيوتنج اكو عالمين، تو وورد. اكو الفيزيبل وورد which هو يحدد قوانين الميكانيكيه، وهي نيوتن لو والثيرمودايناميك لو والميكانيكال لو والالكتريكال لو. لان هاي شغلات is visible, you can touch it, you can explain it by هالقوانين. والانفيزيبل وورلد which is بالنسبه لنا بالاضافه الى الفيزيبل وورلد هو الاجرام السماويه والفضاء والمجرات. الانفيزيبل وورلد بالنسبه لنا كبشر انه هو الاتوميك بارتيكل والفورسز والنيوكلير فورسز والسب اتوميك فورسز. بالحقيقه الانسان يسعى، يعني العلماء بالفيزيكس والماث والساينس يسعون الى يريدون يعرفون شنو اصل الماده. اذا قبل سنتين ثلاثه اذا بوكس هيجن من سوى الانشطار مالت الاتوم مالت النيوكليس، بدها تطلع جسيمات جديده. هو بالحقيقه كل السعي بالفيزيكس يريدون يعرفون what is the origin of the matter. فبهذا الطريق اجت عمليه الكوانتم ميكانكس. هذا بس صوره توضيحيه تشوفك لك من تدخل بالنانو، من تدخل بالنانو سكيلز which is 10 to minus 1 meter which is تقريبا اصغر من حجم ثخن الشعره مالتك، لان الدي ان اي مالتنا هو 2.5 نانومتر. فتصور هذا العالم العميق هو من يدخل به يجي الكوانتم ميكانيك والكوانتم ثيوري فيلد تلعب به. بس من يدخل بالعالم الفيزيبل وورلد يلعب به الكلاسيكال ميكانيك والشغلات مال نيوتن لو والمجرات. احنا بدنا نحكي على العالم الخفي اللي نشوفه احنا. فبالسب اتوميك وورلد احنا نعرف يعني اكو هواي شغلات ما عدا الالكترون والبروتون. احنا نعرف اكو النيوترون، اكو كل هاي جسيمات تكون الماده السلف يوصفوها بالكواركس. بس من تدخل بالعالم الغير مرئي، يعني احنا ما بدنا نحكي على الاتوم اللي اوريدي تجاوزناها الاتوميك سكيل، نحن بدنا نحكي بالنيوكلير سكيل بالنانو، وتدخل بها الويك فورسز والسترونج فورسز والاكشلي هي كومبينيشن اوف ذا نيوكلير فورسز اتسيلف. فاذا تلاحظ الجدول اكو اتوميك فورسز، بعدين تدخل الاليمنتري بارتيكل، بعدين تدخل النيوكلير فورسز which is هاي ما تقدر تحددها الميكانيكال كلاسيك يفسرها. بالديجيتال كومبيوتنج كلها based on 0 and 1 either circuit on circuit off، ودائما كلها تجي 2 to the power something to the power 0 to the power 6 8 10 12 all it is even numbers not odd numbers. فاكو تعريفين اللي نعرفها اكثركم يعرفوها بس تفيد. من نحكي بالبيت ونحكي either 0 or 1 either on or off. بس البت واحده ما تكمل لك تعطيك معلومات كافيه، فلازم تتحولها الى بايت. البايت هي 8 بت. فذا فيرست 8 بت تكون لك الكاركتر، تكون لك النمبرز، فتمشي بهالشغلات مالتها كلها to the 2 to the power exponential equation. Remember this one, the power is the 2 to the power. هذا اهم شيء. بنحكي على الانترنت بصوره سريعه. الانترنت من اكثر الناس يعني انتم اكثرهم تعرفوا هالشغله، يعني يحكي والله تو كمبيوتر they talk to each other. عندي انترنت ويا بيل ولا روجرز وانا احكي ويا باقي الكمبيوترات. بس بالحقيقه there is a lot of mathematical behind it. The whole internet is governed by two mathematical protocol. يعني هذا بروتوكول بقوانينه بالرول مالته، مو شغله عبثيه يعني واحد جاب تو وايرين ولزقهم بعض والانترنت اشتغل. فاكو الانترنت بروتوكول which is science behind itself by itself. بس really the most important the transmission and control protocol. أنا ليش دا أحكي دا أجي هاي النقطة؟ لأن دا أجي down to the what doesn't mean by the digit 0 and 1 and how the information be transmitted through the wire، وشون معنى من يجي تفسير الكوانتم كومبيوتنج. فقلناها البايت هي 8 bits. من نحكي on 1 terabyte ونتكلم about the 10 يعني we talking about 1 trillion bytes. هذا is a huge amount of of data, of information get stored. Could be on a disk, could be on optical, could be on a type of thing. But من نحكي 2 to the power 50, the number is a petabyte. So if you see the amount of the information now, بال 1960 ما قدروا يحكون عن هذا، لأن ما كانت إنه الإنسان يستوعبها. من كان you make I have bought a computer of 16 kilobyte memory that was for things huge. فهذا الديجيتال يونت مالتها نحكي بها. اللي يشوفكم هاي الصورة when you communicate through the internet is internet through this protocol TCP transmission control protocol. بالحقيقة هو how you send your message from one computer to the other computer. You consume information, you get an information. فيلاحظ everything is the 2 to the power 32, 64, 96, 128 is everything. If you do the exponential equation is 2 to the power. بس هذا كله تشوفه there is اكو boxing اني مشيت اكو يسموها الفلاج, which is they basically continue a lot of bytes, which is they control basically the messages, showing the message get received, when the message is received, when they're expecting the next packet coming in. But you see all this overhead on your left, هذا كله packet overhead. Just imagine it as you are like the envelope when you send the letter. envelope in the letter هذا كله يسموه packet overhead envelope. But actually المضمون مال اللتر لازم تفتح هذا الانفلوب. The data what it transmitted is only actually 1500 byte itself. فتشوف اكو دائره بالنص الفلاجز. The flags, which is control a lot of messages, basically which has error corrections, the window size, and all of that. So really, when you communicate to the internet, you send a packet. And when you send that packet, not just one packet, like when you type in and you browse CNN or Wikipedia, you are sending information. All of this information transmitted through a packet. But your actual data is really the one in red at the bottom. And that basically the transmission control protocol control. And that's only two, and كلها 0 and 1, 0 and 1, 0 and 1, and 2 to get in there. Just to get you the idea how really the packet that transmitted. You don't send one packet, you send a stream of packets. These packets get encapsulated through a frame. So how when the encryption work, or the you go and buy on the internet, or you buy from your banking system, all these data is actually getting encrypting in a separate key. And we'll talk about it in a second. Just I want the message, I want to show it to you that there is a lot of math and there is a lot of science, how the things get transmitted on the internet and how the people get hacked to you. Okay, so this we talked about this one. I'm moving very slowly, well, no, a little bit fast, just to get to the point of the quantum computing, which is our main topic. Computer, there is a software and there is a hardware. The software, which is depend on the human being brain, and the software, of course, there is a language and everything. Since a human has ability to do innovation and the thinking and take challenges, diamond software is more advanced than the hardware. The hardware is governed by the electronic law, by the mechanical law, by the environmental law, but what are available to your material. So the software is really moving faster than the hardware, because the hardware, and you'll see in the next slide, it reaches its limit. There is no new material. When the last time you heard about a new material? You have the periodical table, and we just mixed it left and right. And Dr. Yasin يقدر يحكي بهذا الموضوع. We reached to an edge that the material available on Earth is basically to reach its limit. The human being, the engineering, the material scientists, and the electrical engineering, they reach their limit. How basically they can create a new material. That's the reason, if you think about it, they want to go to the moon and go to Marikh or Zuhal. Basically, they're looking for a new material. There is no new material. The periodical table since the 1700 is fixed. There is nothing new material. So that's the problem the computer industry is facing, that you cannot, you'll see later in the slide, we reach our limit to basically to get down to create a new material so we can basically do more computation in the digital world. So we're talking about nanoscale. I just give you some data here about it. There's 1 nanometer is 10 angstrom, which is basically 10 to minus 11 meter. Just imagine the DNA is 2.5 nanometer. When you go to the, we're not talking about atomic, we're talking about the nuclear force. We're going down to the nucleus itself. Is really, there is the distance between atoms, not the atoms, the particle itself. It gets so small that the current, relativity law, the laws we know to talk about the invisible world start breaking down. We're finding a new phenomena, a new جسيمات, new particles coming to us, which is we didn't know about it. So really, we go back to the first slide. We are reaching basically the point to know what is the essence of the matter. What is the matter itself and how it's compute itself here. So this is we are talking about the nanoscale world. Here, I give you some example. Advancement in integrated circuit is basically we like on a single silicon chip, we double, we triple, we quadruple every 2 years. So since 1972, we are able to put more electronic circuit, and this is the advancement of the photolithography in this very small space that basically see the integrated circuit created in 1972, you have 4,000 transistors. Now in 1922, this is a commercially available chip, not in your computer. This is like we don't know about institution. It has 2.6 trillion transistors. In 2023, but I haven't confirmed it, they went down to the 5 nanometer. The more you go down to the nuclear scale, the physics law we know start breaking down. So there must be a new theory coming along and a new explanation to all these matters. So when you go to 1 nanometer, basically you cannot basically put more transistor in the chip itself because the material itself cannot handle it. I go back to my other point I just mentioned is that we reach the limit of a new material or hygiene material we can create to satisfy the current chip and the digital computation. We know the 0 and 1, it reaching limit. Remember, when you go to the integrated circuit, you are not dealing with just, you're dealing with heat, you're dealing with vibration, you have your electronic problem, you're dealing with cooling, and all of that. We're talking about this chip in 1922. This is it's housed in a special compartment just to cool it down because the amount of the heat generated. Just imagine you're standing next to 4,000, one of these cathode tube compared to 2.6 trillion cathode tube sitting next to you. Just imagine how much the heat will be generated from that. Okay. Really, all the things in the physics law come to very simple experiment in the 1760 by Norton, I think Young. Basically, the question was all the time, is the light is a particle or is a wave? That's really what came down. And what came down to very simple experiment, they called it the double slit. If you look at your right, you have a light source, and then the expectation if the جسيمات I should be تنصدم كلها إلي and I just see a light there. But what happened is that as the light passes through these ثقبين, 2 holes, basically صارت تداخلات موجودة and they كونت a new طيف. The question came down to what is the light? Is a particle or is it a wave? And came down to at the end and that it exists or does not exist. They came to a conclusion in early 1800. They say the light is, you can treat it as جسيمات and you can treat it as a light, and sometimes they live together, light and جسيمات in the same one. And this is really the birth of quantum mechanic and كل هاي قاعدين يفسرون الظاهرة until قريبا late 1800. So what is quantum computing? So I will read it to you. This is a definition from Wikipedia. A quantum computer is a computer that exploits quantum mechanical phenomena at a small physical matter, exhibit a property that both particle and wave, and a quantum computing leverage this behavior using specialized hardware. You're not going to buy a quantum computer in 2030 or 2060 or 2050. No. Quantum computer will be sitting in an institution, like one of these science institutions, and all of us, we're going to use it. We're going to connect to it and leverage it. So really, because it requires special housing, requires special cooling, there is a lot of mechanical engineering behind it. So when quantum computing is in the real world, we deal with the zeros and ones. So when quantum computing, you're not dealing with 0, 1. To more or less to philosophy here. You can have a 0 and you can have it 1. You can have it neither 0 and neither 1, and you cannot have it neither 1 or neither 0. Really what comes down that this, when you deal with it, it can exist in many forms. So imagine if you have a circuit 0 and 1, either 9 and off. When you deal with the quantum computing, is that you have multiple different states for the same thing. But now the question is that how I can harness this one and make it an even number. I can use it itself. So really you have to think, so when quantum computing, it has two fundamental phenomena is the superposition and entanglement. So if you understand these two principles, that was all about superposition. You have to really put some, I call it philosophy with the physics, math, to put it together so you can imagine it. Same with the light. We call it is a photon. So it is neither a wave, neither a particle. Sometimes it behaves a wave and sometimes it behaves as a particle, and sometimes it behaves both. So really it came to that, the principle of the possibility and the duality itself. So that the superposition is a fundamental principle of quantum mechanics. Particle can be superposition in different states, not like things like position, momentum are always well defined. So it's really, that one comes down the entanglement. I hope you just take a picture of it, that you are not dealing with fixed something tangible we see. Like, circuit either on and off, light either on and off. There is nothing in between. Here there is something in between. It has existed. Just imagine it from philosophy point of view. So the quantum bit, we're not dealing with a bit, they call it a qubit. Okay. So really it came from two principles, the superposition and the entanglement. Ability to represent, compute upon multiple states simultaneously. Because in a real computer is that you either 0 or 1, and basically you build your digit on that. So there is the certainty is there. When you deal in the quantum computing is uncertainty. So now we come to say, okay, how I can get a value out of that if I don't know if it's 0 or 1 or neither 1 or 0, how I can work it out and make it do that computation for me. The entanglement, which is another principle, is a combined state of a qubit contain more information data than a qubit do itself. Basically, a qubit by itself does not have a value compared to multiple qubits, because they can live together and they can communicate with each other and they know their state. So I hope I explain it, because really this is, even for me, is beyond me, but I try to really bring it down to two states. So just keep in mind, you're not dealing with yes or no. You're dealing with a possibility, a probability, and all of that in between. So now how are we going to harness this power? So I give you the entanglement representation here. Basically, this is a fact here. The qubit is the measuring unit of the quantum, Q for quantum. QU is a quantum bit compared to the classical bit we know it. So if I have 2 qubits, this actually represents 512 bits. When I go to 30 qubits, see the power here. I'm talking about 70 gigabytes. So 70 gigabytes times 8 and do the math for that itself. So see the amount of when you do one. So the quantum mechanics, it helps us to have more computational power compared to the classical computer. When you go to 280 qubit, basically all the atoms in the universe cannot compete with that. So you have to do the math because of the extrapolation and the math for it. This is maybe a difficult slide even for myself, but really that slide took it from a journal. So imagine that when we reach the 100 qubits things, is that basically remember that we say we go to the nanoscale. That basically we go to the atomic scale itself. That basically when we run out. Okay. Let's think about the power of computer. This is I'll give it to you a very simple example. كلكم يسوون banking on the internet. تمام. Everybody has online banking. يروح CIBC, يروح BMO, check his banking account. And of course, all the time you see the lock on the top, which is basically the SSL encryption key. So the SSL encryption key, 2048 bits, which is basically, this is a secure socket layer encryption key. Basically, if you use the most powerful computer we know today, it takes him 30 years to break that encryption key. Okay, just imagine. With a quantum computer, what we have today, it takes only 24 hours. Basically, it comes down to the mathematical calculation for the state, how I can basically get to the right number. So just imagine that the power of this quantum computing, which is going to help us in the problem with the world is going to face, from environmental problem, from food shortages, from finding a cure to cancer, from basically shipping, electronic, and all of that. Just keep it in mind how powerful it is. So now we're going to take two use cases, logistic about shipping. In the shipping, the benefit using quantum computing is really all the shipping depend on time of delivery, and basically what is the last mile for delivery, and you basically it calculate the ship leaving Shanghai in China and to arrive at Los Angeles. Basically, take into a calculation taking the weather, the state of the ocean, take القواصن بالبحار, الأمطار, الرعد, كل الزوابع, كلها تاخذها بالكالكوليشن. يعني it can calculate to you what is the best or the most efficient shipping it takes you to that state. بالإضافة, it has affecting the chain, the supply chain management itself. Just give you an example. I think last year, in 2021, when this big green ship basically blocked the Suez Canal, it cost $10 billion in a trade the moment the ship basically blocked the canal. So in a quantum computing, it can calculate what is the ship which is left their port either at Shanghai or Dubai. Basically change all the routing, say, okay, what's the most efficient way to get to this? Basically to optimize maritime time routing. So that basically you need that power to calculate all of that. بالإضافة, it calculate like if the yard is on strike, is the yard has enough shipping containers to carry on, did they have enough people, and all of that itself. The next one is electronic industry, which is really the most interesting one. Is that, as I said earlier, we reach our limit. There is no new material we can develop. We can basically figure out what we are doing is that with the last whatever left in our hand. So usually, but not just that, the material is not available. Remember the integrated circuit in 1960, the work started on it in 1940. It's only become commercial in 20 years. With a quantum computer, you can do simulation, you can do testing, you can do all of that, and basically reduce the cycle of a new material or a new product come to the market from 20 to 30 years to basically to talking about weeks or days itself. And then basically combined with AI and smart manufacturing is basically to help in the electronic industry. Just to give you a fact that integrated circuit, the one in Taiwan, manufacturing facility, if they want to build it alone, is that it costs $25 billion. You know, the chip that today you get it in your computer, and the facility there, it costs $25 million to build because it had to have very clean room, it had to have high-tech industry and all of that. But you can do all that simulation for a new material using basically quantum computing. And on the top of that, we have now, the other things we just expand on the topic, is that we have so much information in the internet. So how you know that information, if you use artificial intelligence, AI, or you want to use anything, is that how you know this data coming from different sources, from China or from India or from Czechoslovakia, because it can read all this information in different language and basically it analyze it and tell you, the fact from the fact itself. So really, because the AI is driving the need for a quantum computer, because we don't have now to wait 20 to 30 years to create a new chip. Remember, the challenge here is that when you get to the 1 nanometer, you cannot make a new chip, a new transistor. Basically, you hose all of that in a small one. I showed you a basic example. 2022 at 7 nanometer wafer, they were able to put together 2.6 trillion transistors. Okay, just imagine the limit of that, because all the power and nuclear forces will kick in. So I'll show you a recent progress, and this is IBM, by the way, is a leader in quantum computing. They manufacture it, they make it, they do research on it, and also they are cooperating with some institution in Japan and South Korea. So this is the reality. It's a quantum computer in operation. In 2019, the Falcon version was 27 qubits. In 2023, it's become 1,000. And that one, 2023, I put it, that one, they start using quantum computing. We are at the stage of leveraging application and make use of it. 2024 or beyond, they are aiming to 1 million qubit itself. And they expecting in 2023, 30, they will be the first commercial, not in your home, will be an institutional quantum computing, which is all of us will connect to and leverage the data itself. It's a reality, is already happening, and all of that. So before I go here, so somebody will ask the question then, okay, 0 and 1, I know it is a reality, 0 and 1. There is no dispute about it. Either the circuit on is off. So how I can take all these, the entanglement state and the superposition state and the zeros and the 1 in a qubit does not exist in real estate. Let's call it, it is all over the map. So how I can make this one and harness it to make something out of it, which is, as an integer similar to the 0 and 1. Really, it came down to, I'm going just to go quickly on it, come to the Shor algorithm. Is a scientist from, I think, Pennsylvania or US. Basically, he developed the mathematical equation they call the Shor algorithm, because at the end of the day, you need to make numbers out of all this, a quantum state. So that really the scientist, which is he figured it out. And of course, if you Google this guy, the equation is really, is about 3 meters long itself. And this is all the time come to the genius of mathematical things. Okay, so just his name is Peter Shor in 1994. That the reason came to make reality. If you go back one slide, 1994, actually 2016, is the first quantum computing IBM developed, which is, I believe, was 6 or 8 qubits, the speed of it. Okay. So what is the challenge? There is a lot of challenge of quantum computing to make it valuable, but they are aiming for 2030, basically high cost. You required a lot of research scientists, mathematician, and a lot of big pocket behind it. Required a lot of research, development, mathematical, and else really for use for institutional, not for your regular use. But really, the challenge for you for quantum computing is they call it too noisy. Basically, they have to come and fix the error correction. So when you get this data, how you know the data coming out from this quantum calculation is really true or not, doesn't make sense or not. So there is a lot of mathematical modeling behind it. So I really at the end of my things, and I just want to show you. I hope you see the first one. I hope you see that. This is a book from IBM. It's called The Quantum Decade. As I just received the first copy today. I hope you see that. It's very nicely printed book. This is the third edition. Not just IBM, there's other people. So we'll ask you a quiz before I really end my presentation. I hope I did not fly very fast to that. So you listen to my presentation. I hope you enjoyed it. So the question, you can unmute yourself, leave the recording going until we finish. So what is the most super critical education subject that will be in a great demand now and in future? So really the question, name for me the course or the subject. It had to be the course and subject, one word or two words. Okay, Dr. Mihar, you are on mute.
أنا بالنسبة للسؤال أنا ما محضر الإجابة بصراحة، تفاجئني بالسؤال الأخير، بس أنا كان عندي يعني استفسار.
لا عندنا نحكي على السؤال هسه، من يقدر يجاوب على السؤال؟ لسه سمعت المحاضرة مالتي؟
نعم.
ممكن تعيد السؤال؟
موجود على السكرين.
What is the most super critical education subject؟ يعني هل السؤال هذا محصور في المحاضرة اللي حضرتك تطرقت لها أو أي سبجكت آخر؟
لا على المحاضرة السابقة.
بس السؤال اللي يقول what is the most super critical education subject؟ then that هذا is wide، يعني any subject that includes all subjects.
Just give me an answer. So what is the subject if you want to tell somebody, you want to give him advice what he should know?
The title.
Well, this one, the quantum is well, this is the most difficult one, of course.
Okay, well, let's skip the question. That's fine.
I also can say just computing still.
Okay. So
nano engineering, Dr. Rashid?
No. Okay, so anyway, just I thought let's see. Okay, so that's the reference, and I am done with my presentation. Thank you very much for your listening. Appreciate it.
شكرا دكتور رشيد.